How's it going, guys? Today we're gonna do an exercise that involves continuity, but involves two unknown values that we need to find. So it said, set f of x, this piecewise function, find the values of c and d that make f continuous on minus infinity to infinity, which means the whole real line. So how are we gonna do this? Well, first of all, let me remind you what the definition of continuity means. A function is continuous if the limit when x approaches c of f of x is equal to f of c. But notice this limit must exist. So the existence of the limit is that the limit of the left of f of x is equal to the limit of the right of c, right? So in other words, all of these conditions must be satisfied in order to the function be continuous at the point C. Okay, so let's verify our piecewise function and see what are those points that we should verify continuity. Well, clearly, like in the other videos, you always verify continuity where there's a where there could be a breakage of the functions, right? So where could this function break at? So at -1 and at 2. So those are the 2 points that we need to be very careful in order to find continuity for this function. So that's what we're going to evaluate. So let's start with -1. Again, in order for the limit to exist, it must satisfy this condition. So if we choose -1 from the left, we're actually choosing this function, 1 minus cx plus dx squared. If we choose -1 from the right, we're actually choosing this one, x squared plus x. And if we find f of -1, notice the inequality tells me here that there's equality at -1, so we choose this one as well. So for that one, we don't need to find f of -1 because it's already included in the limit from the left of -1. Okay, so no more talking, let's get to work. So limit when x approaches -1 from the left, again is the first one, so 1 minus cx plus dx squared. And that must be equal to the limit approaching -1 from the right. So the limit when x approaches -1 from the right, which is x squared plus x. Okay? Now we plug in -1 in the left function and we equal it to -1 in the right function. So 1 minus c times -1 plus d -1 squared equals, and then we plug in -1 in this function, -1 squared plus -1. Sorry about the lagging. So negative c times -1 is plus c. -1 squared is just +1, so this is plus d. -1 squared is 1. -1 is just -1, so 1 minus 1. Okay? So c1 plus c plus d is equal to 0. Okay? Now, that means that c plus d equals -1. Okay? So, notice that there's still no way to find what c and d is. So in order to find C and D now, we need to use the second fact that we need to find continuity at the point 2. So we do exactly the same that we just did for the point 2. So let's scroll a little lower. There you go. So here, let me change my colors. So limit when x approaches 2 from the left. If I approach 2 from the left, I'm approaching x squared plus x. So x squared plus x. So that must be equal to the limit when x approaches 2 from the right. Okay? Which is this bottom one, cx squared plus dx plus 4. Okay, so, and again, it has to be equal to f of 2, but the equality is already in this function, so it's redundant to write it. And there's going to be examples where the equality is outside of the inequalities. So there you have to be very careful. But this problem, the equalities are already in the inequality. So now we plug in the values, so you get 2 squared plus 2 equals c 2 squared plus d times 2 plus 4. Okay? Now 2 squared is 4 plus 2. So this is 4c plus 2d plus 4. Okay? So now we keep solving it. We have 6 here minus 4, right? Because I'm going to move that negative 4 to the left, equals 4c plus 2d. So 6 minus 4 is 2. Okay. Now notice that we can factorize a 2 from the right side. So 2 becomes 2c plus d. And then we can divide that 2, and then we have 1. So 1 is equal to 2c plus d. Okay? So now we have two equations. So c plus d equals -1, and 1 equals 2c plus d. So let me see. What can we do? We have 2c. Let me write it together. Make a system of equation. And we have 2c plus d equals 1. Okay? Now, in Algebra 2 or in Pre-Calc, wherever you took the class, you learn how to solve systems of equations, right? You're going to use elimination or substitution. I'm going to use elimination because it's just easier for me in this problem. Okay? So elimination means that I have to multiply the top one by -1. So this becomes, so I'm going to multiply -1 by everything, basically, even the equality. So this becomes -c minus d equals 1. Okay? And now I'm going to add these two together, right? So 2c minus c is c. D minus d is 0. And then 1 plus 1 is 2. Therefore, c is equal to 2. And now you can substitute 2 in any of the two equations to find d. Usually I tell people to use the easiest one. So I'm going to choose the first one. 2 plus d equals -1. Therefore, D equals -1 minus 2. Therefore, D equals -3. Okay? And those are the two values that are going to make this function continuous. Okay? Now, remember, now the function becomes what? You need to substitute those two values in order to use the graphing utility. I won't do that in this video. If you want me to do it, leave a comment below. But this will be all for today. If you like the video, like it, subscribe to Motival for more videos, and I hope you enjoyed this video as much as I did making them. So have a great day.